Good morning, dear students. Welcome back to a YouTube class. So, in the last two sessions, we started to know about your 12th chapter, the last chapter of your C++, that is data file handling. So, till now, that is in your first session, we had seen all the introduction part, basics relating to your data file handling, and then we tried to know about the meaning of file, the meaning of your input operation, the meaning of your output operations. These are all the points we had seen. And in the last session, in yesterday's sessions, we tried to know about your stream. What do you mean by stream? What do you mean by input stream? What do you mean by output stream? I had also given you one extra meaning, that is error stream. Actually, this error stream has been considered in your output stream only, but it has its own meaning when we use it, how the data is flowed in your error stream. Fine. Then we had also seen one diagrammatical representation where we had tried to see how your output stream, input stream will be there, from where the data is flowing, that is from disk to file, program to file, and when the data is flowed from memory to file and file to memory in input stream or output stream. These are all the points we tried to know in your previous class. So before moving to the next point in your data file handling, here today let me do a little bit revision on your streams and type of streams. As we had already seen the meaning of stream, so here stream is nothing but the sequence of bytes. The stream is nothing but the sequence of bytes, that is nothing but the flow of the data. So here in your data file handling, we are dealing with everything relating to your binary data. We are dealing with everything in your binary data because we know that the machine understands only your binary data. The machine understands only your binary data. So the data flow in your stream is nothing but at the lowest level. Lowest level means it is in the machine language, that is in the format of your binary data. So here the flow of the data is in the format of binary numbers, that is in a binary data. So we define your stream as the sequence of bytes. Why it is called as sequence of byte? Because it is relating to your binary data, and the binary data means it is 0 and 1, that is bits, and the collection of 8 bits we call it as the byte. So here the stream is also called as your sequence of byte. What is your stream? Stream is nothing but sequence of byte. Stream is a sequence of bytes, that is the flow of data. Flow of data it is called as. So which data? That is your binary data. Which data we are speaking about is your binary data, and it is at low level. That means machine language. That means your machine language. Right? So here your streams has been divided into two types. As I told you, those two types are nothing but the one is input stream and another one is your output stream. One is input stream and the another one is your output stream. So what is your input stream? The input stream is nothing but the stream that supplies the data to your program. The data to your program means here the data is flowing from program file to program. The data is flowing from file to program. So that stream is called as your input stream. That stream is called as input stream. Fine. So your input stream is nothing but the stream that supplies the data to your program. Means we are trying to get the data from the file and we are transferring it to your program. We are trying to get the data from your file and we are trying to transfer it to your program. So what is your input stream? The data is flowing from file to program. File to program. It is reverse in your output stream. It is reverse in your output stream. So what about your output stream? Here the stream that receives the data, the stream that receives the data from the program. The stream that receives the data from your program, that is your output stream. So what happens here? The stream where the data is flowing. The data is flowing from the program. From the program to the file. From program to the file. So here your input stream, the data that supplies to your program, and here the data which receives from the program. So here the data is read from your file and transfer it to your program, and your output stream is nothing but the data that writes and received to your program. Received to your program. So in all, just you have to remember, input stream means the data is coming from your file and going to your program, and output stream is nothing but the data is coming from your program and storing in your file. That is your output stream. So with this input stream and the output stream, we had one more stream that is called as your error stream. So what do you mean by your error stream is, it is a part of your output stream, and when you are writing your program and you are executing and storing it in your file, sometimes if any mistakes you did in writing that program, those errors will be occurred. Those error messages are displayed on your monitor screen, or else those are transferred back to your files. Those flow of the data or that messages are called as your error stream. Are called as your error streams. So this is about your input stream, output stream, error stream, and the general meaning of your stream. Fine. So stream is nothing but the sequence of the byte, that is the flow of the data, and here data is nothing but the binary data that is at the low level. The flow of the data is there at the low level, that means the machine language. Just understand why it is called a sequence of byte, because that data which is flowing from file to program or from program to file is in the format of your binary data. It is in the format of your binary data, and that is at the low level. And we know that the low level flow of the data is nothing but communicating with the machines. Communicating with the machines. And here machine understands only one language, that is your machine language, in the format of your binary numbers and the binary flow of the data. Fine. So here your streams has been divided into two types mainly, input and output stream. The separate error stream is there, but that has been not decided by your syllabus. When you learn it in a detail in higher education, that time you will get to know exactly the separate type. So timing as error stream is a part of your output stream. We consider only two types of the streams, that is input stream and the output stream. Input stream is nothing but the data supplies to your program, means here the data is reading, taking from your file and flowing it to your program, and your output stream is nothing but the data that receives from the program and we read it or send it back to your file, that is your output stream. Then so we had seen one diagram how this data is flowing from one stream to another stream, where it is going means from memory to file or file to memory, when it is called as read the data or write the data, data input, data output, that all. Let me draw the diagram one more time, so it will become the revision for you all. So this is the first one, is your disk file, we call it as, means the data is stored in the format of files, and those files are usually stored in your disk. The files are usually stored in your disk. So from your file it will come to your program, so that is we call it as input stream. That is we call it as input stream. Then from your input stream it will go to your program. So the data which we enter in your program through your output stream, it is again sent back to your disk file. It is again sent back to your disk file. So the data we are taking from your disk file, it is called as read data from. Read data from file. Fine. And here the data from the program, it is going back to your file. So we call it as write data to file. Write data to file. So as the data is moving from your disk files to your program, so we call it as file to memory. The data is going from file to memory. And here the data is coming to your program, means it is input data. It is input data or data input. And here the data is going from the program back to your disk, means it is memory to file. It is, we call it as memory to file. And as it is going out from your program, it is called as data output or your output data. Data output or your output data. Fine. So with this diagram, you can simply see the differentiate between your stream, input stream, output stream, and how the data has been flowed from one part to another part. Fine. So with this, in the last class, we had also seen one header file that is called as fstream.h. fstream.h. So this is a header file. I had given a little bit introduction part only. I had given you only the introduction part relating to this header file. Now in today's class, we learn in detail relating to these header files. Relating to this header file, today we learn in detail. Fine. So this fstream.h header file is used in your C++ language when all we are performing the input and output operations relating to your files. When all we are performing the input and output operations relating to your file or on your file data, then we include a header file from your standard library of your C++ language, and that header file is called as your fstream.h. That header file is called as your fstream.h. So the C++ input output operations are very much similar to your console input and output operations. So we had writing C in, C out. For that we are using your conio.h header file. When you are writing console input, console output operations in your program, that is C in for reading the values and C out for printing the value on your monitor screen. To perform these operations, we are using a header file called as your console input output, that is conio.h header file. Fine. Similarly, the file operations also make use of these streams. The file operations also make use of the streams as the interface between your programs and the files. So here the stream is a general name given to your flow of the data. As I told you already that the data is flowed in a lower level, that is in your machine language, and that is in the format of your binary data, and it is called as your bytes. So it is a general name, a flow of a bytes. Actually we have to call it. So generally it is named as your stream. Then, so when all you are performing any operations, means taking the data or giving the data, that is through your input stream or the output stream, or you are performing the input operations or the output operations. For this we have a standard library, and that library supports you one header file that is called as fstream.h. That is called as your fstream.h. Then, so here in your fstream.h we have mainly three classes. One is called as fstream, another one is called as fstream, and the third one we have is offstream. We have fstream class, we have ifstream class, and we have offstream class. So for what purpose we use these classes? IfStream class will help you to perform all the input operations on your file. All the input operations on your file data. If you want to perform any input operations on your file data, then we use this in IfStream class. If you want to perform the output operations on your file data, then we use this OffStream class. When to use IfStream class and when to use OffStream class, or when your IfStream class has been supported and when your OffStream class has been supported is when you are performing the input operations on your file data, that time IfStream class has been used, and when you are performing the output operations on your file data, then OffStream class will be supported. And this FStream class gives you both input and output operations. Both input and output operations on your file data. When you are performing both input and output operations on your file data, that time we use a standard class is called as your FStream. Right? So here FStream will act like a base class, where your IfStream and OffStream are the part of your FStream, means the derived class of your FStream, you can call it. Because in your FStream, we can perform both input and output operations, where in your IfStream, only the input operations are going to be carried out, and in your OffStream class, only the output operations are going to be carried out. So in your FStream, both input and output combinedly can be carried out. So when you see the classification, that time we can just observe that this IfStream and OffStream are the derived class of the base FStream class. Here FStream will act like your base class, and these will act like your derived class. These will act like your derived class. Fine. So we'll see now the stream class hierarchy of for your input output operations. What we'll see, these are the general things we have learned in the previous class. Now we'll see the next part, that is the stream class hierarchy for your input output operations. Means there are different input operations and the output operations which we can carry out on your file data. Now how this data has been flowed in a hierarchy from your classes, one class to another class, which is a base class, which is a derived class, that all hierarchy we'll try to study it. So the next part comes is stream class hierarchy for input output operations. For input output operations. So here we try to see first the stream class hierarchy for your input and output operations. So when you have studied your fstream.h, that is your fstream.h header file, in that the input output system of your C++ contains the set of classes that define the file handling methods. So when all you want to handle your files with your input output operations, that is in your C++, that all will be defined in your fstream.h header files. So these includes your ifstream, offstream and fstream classes. It includes all your ifstream and offstream classes. Then so these classes are derived from your fstream base class. These classes has been derived from your fstream base class and from the corresponding iostream.h. iostream.h. So these two has been derived from your fstream also and can be a part of your iostream.h also, because the iostream is nothing but input output stream, and these input and output streams has been carried out here with your iostream also. So these can be the part of your fstream class also and iostream class also. So your ifstream and offstreams can be derived from your base class, that is fstream, and even the base class from your iostream.h. So these classes designed to manage mainly the disk files. These classes has been mainly designed to manage your disk files are declared in fstream.h. You all are declared in your fstream.h header file. Therefore, we must and should include this file in any program that uses the files. So when all you are trying to define your classes, or when you are trying to write the program relating to your file handling data, that time compulsorily you have to use a header file called as fstream.h. Done? So now I'll show you one diagram. So just see that diagram and then we'll try to see the hierarchy. Okay, so first let me draw that hierarchy, then I'll explain how this hierarchy is there for your input-output operations of your stream class. Done? So at the top we have is IOS, that is input-output system, or you can call it as input-output stream. Next comes is 3 boxes. I stream, this is O stream, and this is stream buffer. This is stream buffer. Fine. Next, one more box comes here, is IO stream. I'm writing a little bit font with a less because it should fit in this. I'll explain it, what it is. Okay, you can take it. So just listen to the wordings if it is not visible, and you can note down. So the next level comes, this is if stream. Then comes F stream. And then comes off stream, and then comes file buffer. Then comes file buffer. At the end, here we'll get fstream base. At the end, here we'll get fstream base. Done? Now see the hierarchy. Through your IOS, IO stream has been derived. Your I stream and stream buffer has been derived. Using your I stream, if stream and this IO stream has been derived, and using this O stream, your not this connection, it is comes here. It comes for this, okay? Cancel it. From your O stream, O off stream and IO stream has been derived. And from your IO stream, your F stream has been derived. And from your stream buffer, your files buffer has been created. Done. Now, this IO stream and from this IO stream, this F stream base has been derived, and from this F stream base, F stream, off stream and this if stream has been derived. So I can divide now this into 2 parts. This part is relating to your IO stream.h, and this part is relating to your fstream.h. I am writing here fstream.h. Done? So concentrate on your diagram. First I'll tell you what is there in your diagram, then I'll explain it. Fine? So just concentrate on your diagram. This is IOS, input output stream. Through this I stream, O stream and stream buffer has been derived. Through this I stream, if stream and IOS, from your O stream, IOS and off stream. IOS and off stream. Now from your stream buffer, file buffer. From your stream buffer, file buffer is there. Next, IO stream has been derived by including I stream and O stream. It has both the features from your I stream and O stream. Next, from your IO stream, if stream is there, from your I stream, from your IO stream, F stream is there, and from your O stream, off stream is there. Now, through your IOS, your F stream base has been created, and through this your F and off stream has been derived. Through this, your F and off stream has been derived. Now I can divide it into two parts, the entire hierarchy. This part, that is I stream, O stream, IO stream and stream buffer, is relating to your IO stream.h header file. These all the classes comes under IO stream header files. And this if stream, F stream, off stream, file buffer, these all will comes in your fstream.h header file. Clear? Even though F stream, off streams are a part of your IO stream, because these are derived from the streams also, that is I stream, O stream, and even from your F stream base also. So these can be included in your IO stream and both in F stream. So when all we are using any operations, or when all we are performing any operations relating to your files for your if stream, F stream and off stream, rather than using iostream.h header file, we prefer of using fstream.h header file. We prefer of using your fstream header files. Done? So how this hierarchy is taking place, which is the base class, which is your derived class, that we'll see now. So before seeing in detail relating to your hierarchy, let me tell you some words. IOS means input output stream. Stream means the flow of the bytes. Here byte means the binary data, that is the flow of the data in a lowest level. Fine. Next, I stream input data, O stream output data. Next, IO stream input output data, IO stream input output data. Then if stream input file stream, F stream file stream, off stream output file stream. Next, stream buffer and file buffer. So before seeing with the term stream buffer and your file buffer, let me tell you what do you mean by buffer first. What do you mean by buffer first? So here buffer is nothing but the physical memory storage. Buffer is nothing but the physical memory storage, means the data is storing in your disk or the file. The data is storing in your disk or the file. You entered some data in your Word file. You entered some data in your Excel file, or you have created an image, that is an image file. So you are storing, that is saving in your memory, maybe the main memory or your secondary memory, that may be in your RAM or that may be in your hard disk. So buffer is nothing but the data which you are storing in your physical memory. The data which is stored in your physical memory, that is called as your buffer. This buffer will act like a temporary storage. This buffer will act like a temporary storage. It is used when you want to move the data at the time of processing. When you want to move the data at the time of processing, that may be from I input or output stream, or at the time of your input file stream, output file stream, or both. Whenever you want to move the data, that time we use this streams buffer. Okay. So what do you mean by your stream buffer, and what do you mean by your file buffer? So stream buffer is nothing but the data relating to your streams, and file buffer is nothing but the data or the storage relating to your files. Fine. Now we'll see what is this all working with. What these all are the working with. The first one will start with your file buffer. This file buffer sets the files. The file buffer sets the file to read and write operation, to perform your read and write operations. So for what purpose use this file buffer? So let me write file buff. This is used to set your file buffer to read and write operation. set the buffer, that is the temporary area, storage area, to perform your read and write operation. To perform your read and write operations. Next, fstream base. Fstream base. So for what purpose we use this fstream base? So this fstream base provides the facility for file operations. It provides the facility to perform the file operations. It will perform the file operations like input operations or the output operations. Input operations or the output operations. That may include the close and open member function. That may include your close and open member functions, and this is the base class for your ifstream, fstream and offstream, because using this ifstream and offstream has been created. Using this ifstream base class, ifstream, fstream and offstream is derived. So this will act like a base class for ifstream, offstream and fstream class. Then, so for what purpose use this fstream? It used to perform your file operations. Used to perform the file operations. So the file operations includes two member functions. One is open and another one is close. One is open and another one is close. And this is a base class for ifstream, fstream and offstream. If you can see this diagram, you can just concentrate. You will get to know through this fstream base, these has been created. The arrow is going to these. So this is a base class and these three are derived from this base class. Then, so understand, relating to fstream base, this is used to perform the file operations and it has a member functions. One is open and another one is close. Then to perform the operations on your file, we use open. We need to open that file, and after the performing the operations on that file, we have to close that file. Then, for example, if you want to type anything in your Word, you open a Word file, and after completion of that file, you close it. That is the close operation. Fine. Next, here fstream will act like your base class, and using this base class, we have derived the three other classes, that is ifstream, fstream and your offstream. Next comes is your ifstream. Next comes is your ifstream, that is this part. Here in your ifstream, this ifstream, it is a stream class to read from your files. It is a stream class which is used to read the data from your files, and it provides the input operations for your file. When all you want to perform any input operations on your file, that time we use this ifstream class. And using this ifstream class, we can perform the other functions like put function, write function, seek p and tell p. Then, and that is from your ifstream class. Ifstream class is used for what? It is used to read the data from your files. Read data from files. Read data from files. So it is used for what purpose? We use to perform the input operations on your files or on your file data. Input operations. When you want to perform any input operations on your file data, that time we use a class called as your ifstream class. Then, so here in your ifstream class, we can perform the different functions from your istream class. That is, the ifstream class inherits the functions using your istream class. Which all those classes? The one is get function. Next we have is getLine function. Then you have is read function. And then you have is seekg function. and the last one telg functions. So when all you want to perform the input operations on your file, those operations are like get, getline, read, seekg and telg. And when you want to perform these operations, input operations on your file, you have to inherit these functions using your iStream. Using your iStream class. For that reason, there is a connection between your iStream and ifstream. There is a connection between your iStream and ifstream. Understood why there is a connection between the iostream.h and your fstream.h header file? Because there are a class which are supported by your ifstream header file, and those are in connection with your iStream. Because when you are using fstream class and you are performing some of the functions on your file data, we are using those functions from your iStream class. तुम्ही काय करालाय? ifstream क्लास यूज करालाय, म्हणजे काही इनपुट ऑपरेशन्स करालाय फाईल मध्ये, पण ते फंक्शन्स कशात आहेत? iStream मध्ये आहेत, इनपुट स्ट्रीम मध्ये आहे, आणि इनपुट स्ट्रीम कशात आहे? iostream.h हेडर फाईल मध्ये आहे. फॉर दॅट रिझन युअर ifstream and iStream has been connected to each other. Similarly with your ifstream, come to your offstream. We'll study about your offstream. So for what purpose we use this offstream class? The offstream class is used to write the data on your files. Write the data on your files, and it provide you to perform the different output operations on your file. This class will help you to perform the different output operations on your file data. Which all the operations we can perform? To perform those output operations, we have to use the help of your oStream class. We have to use the help of your oStream class. Fine. So with the help of your oStream files, we can perform the different functions like put, write, seekp and telp. Done? So this class is mainly used to write data into files. Write data into your files, that is output operations. We can perform the output operations on your file data. So it inherits the functions from your oStream class, and which all those functions are put, write, seekp and telp. These are the functions coming from your oStream. For that is the reason why your offstream and oStream has been connected to each other. Then you may get a question to explain your ifstream class with its functions, or the offstream class with its function, or you may get a just question, write the different functions of ifstream class and different functions of your offstream class. I had given the list of the function and what this function work, for what purpose we use this get function, getLine function, read function and seekg, telg, and for what purpose we use this put, write, seekp and telp, that all we'll see in the next classes in detail. Then before that we have to study the types of files and all. Then before just timing now, you remember these are the functions performed in your input operations. These are the functions performed on your output operations relating to your files. Then coming to the next class is your fstream. Next class we have is fstream. So here the stream will help you to perform both the read and write operations to or from your files. That is, when you want to read the data from your files or you want to write the data into your files, both functions if you want to perform, then we use this fstream class. So it provides and supports the simultaneous both input and output operations. Both input and output operations. For that reason, it inherits all the functions of your iStream and oStreams, that is coming in your iOStream and that is relating to your fstream. Understand why this fstream is connected to iOStream? fstream म्हणजे काय? ह्याच्यात इनपुट आणि आउटपुट दोन्ही कंबाइंड करू शकता. म्हणजे जे काही तुमचं ifstream मध्ये होतंय आणि जे काही तुमचं offstream मध्ये होतंय ते दोन्ही कंबाइन करून आम्ही fstream मध्ये करतो. Then so as fstream allows you or supports you to perform both input and output operation, For that reason, it is connected to your IO stream, and in your IO stream, it supports with I stream and O stream. It is combined. It has both the features of I stream and O stream. So there is a connection between your IO stream and F stream. Clear? So F stream will help you. It's a class which will help you to perform both your read and write functions to your files. Write and read from or to the files. Done? So it will provide or it will support both input and output operations. Input and output operations. So it will inherit all the functions from your I stream and O stream classes. Then, so this happens backside of your file, backside of your classes. For that reason, this is the hierarchy what we have to study. Then, so file buffer is connected to your stream buffer. Stream buffer is through your iOS. Then, so here if is connected to your F stream, but it is through your I stream because it is performing all the functions which are there in your I stream. F stream combined input output, so it is connected to IO stream, and IO stream has been derived by I stream and O stream. And off stream perform all output, so it is connected to your O stream and derived from your F stream. Done? So this is all what we are studying in your stream and the hierarchy of your stream. Clear? Hope so the points are clear. If the points are not clear, in the next class I'll draw this diagram and I'll give you the rough idea. If you have any doubts, let me know. I'll clarify your all doubts. Done? So time being, for your exam purpose, you have to study this F stream base class, if stream, off stream and file. Remember what is if stream? Which all the functions we are performing in your if stream? What do you mean by your off stream? What all the functions we are performing in your off stream? Done? F stream is combined both input and output operations which we are separately performing in your if stream and off stream. Done? If you have any doubts, let me clarify your doubts. Ask me, I'll clarify your doubts. And the other points relating to your data file handling, we'll see in the next class. Thank you.